Assalamualaikum. My name is AINURYUSRA binti Muhammad ZAWAWI. Today we will present about torsion in actual structure. But first, let me explain about the torsion in solid mechanics. So in solid mechanics, torsion is the twisting of an object due to an applied torque. Torsion also refers to the twisting of the structural member loaded by torque, or twisting couples. The structural engineer typically designs steel members to be loaded such that torsion is not a concern. Okay, we move to the objective of this project. So firstly, the objective of this project is to draw details, free body diagram from the actual structure related problem that we have chosen. And secondly, to develop equation from the free body diagram drawn. And lastly, the objective of this project is to analyze force members from the structure. For the actual structure, we have decided to choose pipe taper. The pipe taper is made from steel and other material that have coated the steel. But we decided to neglect the other material. System involved in this structure is torsion of non-circular. So torsion stress is more difficult to calculate when the cross section is not circular. There are cases when shafts or bars not circular and must withstand a torque. When the rod is not circular cross section, the state of strain cannot be maintained by the action of terminal twisting couples alone. Another system involved in this structure is shear stress. So shear stress developed in a material subjected to a specific torque in torsion test. For torsion of rectangular sections, the maximum shear stress is given by the formula. Okay, lastly, system involved in this structure is the angle of twist. For a shaft under torsional loading, the angle through which fixed end of a shaft rotates with respect to the free end is called the angle of twist. The degree of twisting needs to be quantified to ensure that shafts are designed within safe twisting limits.
Mas Ainur IZZATI binti Mas KAMARULZAMAN. Okay, this is our FBD. For the first thing, we need to calculate the rectangular section first. Okay, we have the value of B and D, and we input to the formula, and we calculate and get the value of dB. And from this, we can get the value of K1 and K2. K1 and K2 we get from the table on our poster. Okay. The second, we calculate the shear stress maximum of the rectangular section. The formula is torque over the K1 multiplied by dB squared. Okay, the value of T is 3.75. Fraction by 0.258 multiplied by 0.005 and multiplied by 0.002 power of squared, and get this answer 726.74 multiplied 10 power by 6 Pascal. For the angle twist of the rectangular section, we use the formula of angle over length. Okay, the angle of twist rectangular section, we use this formula. Angle of twist over L equal to the T over K2 dB cube G. Okay, we need to calculate this. The value of L is 0.075 equal to 3.75 value of T fractioned by K2 is 0.249 multiplied by dB cube is 0.05 multiplied 0.02 cube and multiplied by 18 giga. The value of G, shear modulus for the steel is 78 gigapascal, and we round off the value, we get the 18 giganewton per meter squared. Okay, we proceed to the calculation. After we calculate this and we get the answer is 4.706, and the answer of the angle of twist rectangular section for the radian 0.353 radian per meter. If in degree per meter is 20.225. Okay, for the last calculation of the torsion is for the torsion circular. For the torsion circular that we have is diameter of external is 0.01 meter and diameter of internal is 0.04 meter, and for second is 0.002 meter, and the torsion is 3.75 Newton. And for the polar of moment inertia, we calculate that we use this formula is pi over 2 c power of 4 and get the answer of polar of moment inertia is 23.562 multiple 10 power by negative 12 meter power 4. Okay, for the first shear stress, we calculate and we get the answer 318.309 megapascal, and for the second shear stress we get 159.155 megapascal. So this is the calculation of torsion based on actual structure that we get. Thank you.
Next, I will explain about factor of safety. The formula of safety factor is shear fail over shear allow. After all the calculation, we got the maximum shear stress for the structure that we use. The maximum shear stress of the structure that we have calculated is 726 megapascal. So we assume that the force applied more than 726 megapascal is fail. So we have calculated the FOS and we got 2.066, which is safe for the structure.
For discussion of this project is mainly about analyzing the torsion force of the actual structure. As the objective of this project is to draw free body diagram from the actual structure related to the problem, and is also to analyze force member from the structure. Based on the factor of safety, the structure that have been chosen is safe enough for use with reliable materials where loading and environmental conditions are not severe. In conclusion of this project, we were able to analyze the deformation of the circle shaft when subjected to torque, because of an object can be turned and twisted.